Good afternoon, everyone. Just to let you know, I can see lots of people are still joining the webinar, so we're just going to give it a minute or so to let those final people join, and then we'll get started. Hello, everyone, and welcome to today's exciting session on what we believe represents the next evolutionary leap in artificial intelligence, namely the emergence and rise of visual general intelligence. I'm delighted to introduce our speakers, our co-founders and co-CEOs from Viso, Gauden Bosch and Nico Klinger, and also Jeremy Michaels, our strategic content writer here at Viso. So a big welcome to you all, and thank you for joining today.
Hi, everyone.
Hi. In terms of what we're going to be covering, we will, of course, be introducing you all to visual general intelligence and why it matters. We will be touching on how that goes beyond perception and then onto key capabilities of the application layer, the economic impact, and then, of course, what the future looks like. Jeremy will guide this discussion with our co-founders, and since we have such a big audience today, we do encourage you to drop your questions in the Q&A section throughout. We will try to weave them into our conversation where possible, but we'll also make sure to keep some time aside at the end to cover as many off as we can. Any that we miss, we will reach out to you after the event and address any that we don't get to live. So I think let's get started with a quick poll to help us better understand where you all are as an audience. Talia, if you could initiate that for me, please. The question that we're looking to ask is, where would you place you or your organization's current AI vision maturity? So you should see that go live. You should have options of not using AI vision in any form, rule-based detection system in place, an advanced AI vision in specific use cases, scaling AI vision company-wide, or exploring next-generation visual intelligent approaches. So if you can all go ahead and vote there, we will add that to the stage. Okay, so I can see results coming in. Nico, maybe you have some comments here on these initially.
Thanks, Chrissy, and thank you everyone for having me today. Very interesting seeing the results coming in. And this distribution reflects exactly what I think we're observing in the field. The industry is transitioning from traditional rule-based systems toward true understanding. And that transition is where visual general intelligence becomes essential. And I think most organizations are still in the early stages of benefiting from AI vision. Some have begun to unlock the potential, but I think in every case, there is a big opportunity ahead of us and ahead of the global industry.
Yeah, absolutely. Thank you, Nico. Okay, so time to get stuck into the exciting stuff now. So I'll pass over to Jeremy. Over to you.
Thanks so much, Chrissy, and thanks everyone for joining today. Just briefly to set the scene, I'd say we're living through what Ray Kurzweil called the approach to the singularity. And as many of you will know, that's the theoretical point where AI surpasses human intelligence. While everyone talks about ChatGPT and large language models, We're here to discuss something equally transformative, but less understood. And that's the evolution from computer vision to true visual general intelligence. So starting with the bigger AI picture, as I said, we're all aware of ChatGPT's breakthrough and leapfrog and the emergence of other largely text-based models. It showed us what's possible when AI moves from narrow tasks to general understanding. Many of you may well also be following the ongoing debates about AGI, artificial general intelligence, and that's around when it might be achieved and how we can prove it. But to get started, I wondered, Gaudence, if you can kick us off with how VGI relates to the emergence of AI more broadly and also its future evolution.
Sure, Jeremy. So broadly speaking, the future of AI vision hinges on two complementary paths. On one side, many US tech giants are pursuing artificial general intelligence, AGI, by building AI systems that are capable or surpassing human intelligence across diverse tasks. In contrast, several leading Chinese companies are prioritizing practical and accessible computer vision systems which address real-world needs in sectors like manufacturing, healthcare, logistics, and transportation. So they've been gaining this hands-on experience by deploying AI into the real world, and not just in research or in innovation labs. So it's not a question of one approach versus the other, but when it comes to VGI, it's the application layer. It's the ability to put AI vision to work that will ultimately define success. And ChatGPT demonstrated the power of foundation models, AI systems that can generalize across many tasks rather than being trained for just one. But those large language models have a key limitation. They're mostly trained on text. Text is structured, rule-based, bound by semantics, and relatively low in information compared to the richness of visual data. And images and video are exponentially more complex. They demand far greater bandwidth and computing power to process that. So now we're seeing the rise of multimodal AI, general models that can understand not just text, but also pictures, sounds, even sensory data and video. This shift transforms them from simple algorithms into adaptive digital agents. And that's exactly what makes visual general intelligence possible. And let me put that into perspective. Yann LeCun from Meta, he made a striking comparison. He said, like, by the age of 4, a child has already processed an order of a quadrillion bytes of visual input through their eyes. That's orders of magnitude more than the biggest language models have ever seen in text, maybe 20 trillion bytes at best. So that's about 50 times more. And the point is, humans don't learn by reading billions of words. We learn through constant visual interaction. So by seeing, moving, understanding how the world responds with all of its noise and all of its ambiguity. And that's how humans gain context, common sense, and the ability to reason and understand. That's the big difference here. So if language models were the proof concept for general AI, then visual intelligence will be the proof point for human-level intelligence in machines. Because until AI can reason visually, understanding context, cause, and consequence, it won't truly reflect how humans learn and think. And it's what visual general intelligence is all about. Machines achieving a dynamic, context-aware, and human-level visual understanding across all domains. And that's why I believe VGI may be the clearest and most concrete milestone on the road to achieving artificial general intelligence itself.
You're totally right there, Gaudence. I like to think about it this way. ChatGPT transformed how we interact with text-based information, and VGI will transform how machines understand the physical world in context. So while LLMs excel at language reasoning, VGI tackles something far more complex, namely spatial intelligence, meaning understanding 3D relationships, interpreting complex scenes, and reasoning about physical environments. And the key parallel is that both represent the shift from narrow task-specific AI to more general purpose intelligence. But where GPT handles words and concepts, VGI handles everything that we see and interact with in the real world.
Wow, what a great way to start. Thank you both so much. That is really insightful and comprehensive. So following on from this, I'm just wondering, why is visual intelligence so much more important than language intelligence? Gowdens?
So I think visual intelligence isn't just important, it's the foundation of intelligence itself. Over 70% of the human brain sensory input is dedicated to vision. And there are studies from MIT and Stanford that show how visual perception drives how we reason about the world around us. Hence, if we're approaching AGI, mastering the visual understanding is not just helpful or interesting, it's essential. And in fact, we believe that VGI could serve as the most important proof point that AGI has been achieved, solving problems that humans have not been able to solve.
Got it. Makes perfect sense. So we have computer vision systems deployed across multiple industries today, but what fundamental limitations are holding them back from stepping into this vision of VGI?
Current AI vision systems suffer from what we call narrow intelligence. So they are excellent at the specific tasks they were trained for, but they can't generalize really well. So to give you an example, in construction safety, a system trained to detect missing hard hats can't adapt to recognize improper lifting techniques. That would basically require building and training a new system. And that's also why often companies end up with dozens of spot or point solutions, one for each use case, basically. And more fundamentally, those systems see patterns, but they don't understand the context. For instance, they can tell you that a ladder is leaning against the wall, but they can't infer that this blocks a fire exit and represents a safety violation.
Exactly. And to add to that, the biggest blocker isn't model accuracy, it's everything around it. So getting vision to work at scale means connecting the cameras, managing edge hardware to run the AI model, ensuring privacy and security, and creating insights that then have like a real world impact. And many AI systems don't really tie into existing workflows. There are no natural learning loops and very little real world interaction, and they live in this data science silo. And VGI is achievable when we pair general purpose vision with a very strong application layer. So that includes this simplified configuration in between the model and the infrastructure, security, privacy by design that's built into everything, and humans in the loop with clear integrations into existing processes and existing systems. And VGI needs great systems engineering around the model. That's what it's all about, and not just smarter models themselves.
Great summary, thank you. What about the architectural limitations? Nico?
Most current systems are what we call pixel matching approaches. So they look for specific visual patterns rather than understanding scenes holistically. So they can't reason about intent or context. For example, they might detect that someone is near a piece of machinery, but they can't understand whether that person is performing authorized maintenance or creating a safety risk. That distinction requires integration and a far more sophisticated approach to visual intelligence.
And when it comes to AI vision adoption, the real barrier isn't just about collecting or labeling the training data. That's just a matter of time and resources. It's not easy, but it's very well doable. The deeper challenge that's an actual handbrake in the process is what I call the integration gap. Most systems simply aren't ready to design, deploy, and operate those computer vision systems, let alone at scales. So those organizations have to find ways where it's not just about having a working model in place, it's about embedding it into daily operations, managing infrastructure it's running on, ensuring reliability, and adapting it to constantly changing environments. So lighting changes, weather changes, just like the living world around the model. And most companies find it very hard to build the traditional IT systems like websites or ERP already. And here comes the challenge that AI vision is an order of magnitude more complex to deploy, right? You need teams who understand, have practical experience in every aspect of the required tech architecture. And it's very hard to find those people. And the reason why most ambitious pilots never make it past the innovation lab stage is that solving a narrow problem in isolation is not sufficient to bridge it into delivering real-world business impact.
Got it. So, okay, lots to digest there. We've got narrow intelligence, context blindness, data dependency, and deployment complexity. How do these limitations manifest then in real-world scenarios? Nico, can you give us an example here?
Sure thing. Let's probably start with a manufacturing environment. Current vision systems might flag that someone isn't wearing safety glasses in a specific area. That's useful, but it's still very narrow. What VGI does, it connects the dots. It sees that this same person followed every protocol across 3 other zones, as an example, which may indicate the issue is procedural rather than individual non-compliance. And critically, I think this isn't just about the model itself, as Gaudens mentioned. VGI comes to life at the edge, deployed directly on site, analyzing video in real time. It's not just detecting events, it's configuring to different contexts dynamically, adapting to new layouts or production schedules without needing months and months of costly retraining.
That's absolutely right, Nico. And adding on top of that, VGI integrates also the human-in-the-loop feedback that we mentioned before. It means that people aren't just receiving alerts or notifications. It means that they're coaching the system by using it. When the system flags an event, supervisors can confirm, correct, or add context about why a specific event matters. For example, this object blocks an exit, adding context around the original detection. And that input flows back as feedback into the system to continuously learn and to improve its performance. And it means we have like a closed loop learning system. It means that confirmations improve detection, confidence corrections become training signals, and nodes that shape rules like zones, schedules, or exception lists. And dashboards is where everything comes together. They provide managers with an overview of what happened and the full incident timeline, and not just the missed safety equipment list like safety glass or helmet, but also how it relates to shift changes, training schedules, or equipment downtime. So the result is actionable intelligence. Instead of just extensive lists of isolated alerts, you have connected insights to actually improve safety outcomes, and make compliance part of a smarter and more adaptive system.
Fantastic. That's really brought that to life. So moving on, can we delve deeper into and define what we actually mean by visual general intelligence? And especially, how is it fundamentally different from current computer vision? Perhaps you can kick us off on that one, Gaudens.
Sure. So VGI is artificial intelligence that possesses human-level visual cognition across all domains. Instead of being trained for one specific task, it has a general visual knowledge that it can apply to any scenario. Think of it as giving machines the visual flexibility and understanding that humans naturally possess.
That's so exciting. Application to any scenario then clearly makes VGI potentially limitless. So Nico, can you break down what are the key capabilities that define VGI?
Of course, and let's probably start with general visual knowledge, which means understanding objects, actions, environments, and materials across diverse domains without task-specific training of the models. So for example, a VGI system can recognize a safety violation in a construction site and then immediately apply similar reasoning to a warehouse environment. Then there is also the capability of goal-directed perception. If you think of human vision, you realize that human vision isn't passive, right? We see with purpose. And also VGI systems align their visual processing with specific objectives, prioritizing relevant information based on the task at hand. And then following on from those is context-aware understanding, where VGI doesn't just see static images, it actually understands scenes as part of dynamic environments. And then another key aspect is or what we call visual agency, or the ability to not just see, but actually act based on what is visible on the system or to the system. And that's what enables autonomous action, robotic manipulation, or direct interaction with other systems. And what makes VGI so different is how these capabilities scale. It's not a single demo in a lab, it's systems deployed at the edge in diverse settings, running in real time, configurable across sites, and connected into dashboards and enterprise workflows. With human oversight built in, you get applications that adapt and improve over time. So instead of a one-off model, VGI delivers a platform that can roll out across industries, turning visual intelligence into real-world impact.
Fantastic. Thank you, Nico. That's really clear and comprehensive. So in that context, what about learning and adaptation?
Yeah, that's actually an additional capability, continual visual learning. So instead of freezing after retraining, VGI systems continuously update their understanding based on new environments, tasks, and objects, while retaining previously learned capabilities. So they don't forget, but they accumulate knowledge over time and get better. And then finally, high-level visual cognition, inferring intent, causality, and predicting what happens next based on visual information. So this is anticipation and not detection, where VGI reads intent and context, such as an operator reaching over a moving conveyor belt, and then the VGI system predicts that a hazard is about to happen before it actually happens.
Wow, that's great. So we've got then the 6 key capabilities brilliantly summarized there. Thank you. That makes me think about what it means to declare that we've actually arrived at VGI. Clearly, this is one of the hottest debates when it comes to AI. So, how do we know when we've reached AGI or artificial general intelligence? With regards to VGI, might that possibly look like a visual Turing test? I'm referring to Alan Turing's test of a machine's ability to exhibit intelligent behavior, and that behavior being indistinguishable from that of a human. Gowdens, could this maybe be a way to measure VGI achievement?
Quite possibly, yes. Instead of asking whether a machine can hold a conversation that we cannot differentiate from the ones a human may have, we might ask, can we interpret and respond to visual scenarios with the same relevance and insight as a human observer, how it's so natural to humans? Can a VGI system look at the loading dock and not just detect the people who should not be there, but also identify the hazard that occur by people just waiting in dangerous areas, and explain why they're hazardous, predict likely consequences, and suggest contextually appropriate interventions? That's the benchmark we're working towards. It's very complicated.
Yeah, sure. That is a true benchmark indeed, which leads me to considering what the technological building blocks are in place that are making VGI possible now. I wondered what your thoughts on that might be, Nico.
Certainly, Jeremy. I think there are several factors that are creating this inflection point. Looking at foundation models, and we discussed it before, in the LLM space, they have shown us how large-scale pre-training creates adaptable systems that can be applied to different domains. We're seeing at the moment the emergence of large vision models that bring this foundation model approach to the visual domain. Then secondly, hardware democratization means that high-performance processing is now affordable and accessible to everyone. Edge computing brings AI closer to the data sources, solving for latency and bandwidth challenges. So to put it simply, you place a computer near the camera, so it analyzes footage on site and only sends results and not all the raw data to the cloud. And then perhaps most importantly, we're seeing breakthroughs in data efficiency as well. Modern approaches require far less labeled data through techniques like self-supervised learning and synthetic data generation. So we are moving away from annotating thousands or millions of images to more fine-tuning models for specific environments.
Fabulous. Thanks, Nico. Okay, let's shift gears a little bit. Gowdens, you mentioned the application layer earlier. everyone's focused on AI models, but you outline quite rightly that's only one part of the equation. So why does the application layer matter so much for VGI?
Can't hear you, Gardens.
They clicked the mute button a bit too early here. Yeah, so so I'm gonna recap everything I just said. So yeah, here's the reality. The application layer is basically the central source in VGI. A model itself is just a mathematical function to transform input data into outputs, and the application layer is what transforms the function into actual business value. And without business value, I would argue all of this remains more theoretical than impactful. That's the shift, that AI vision is a method for solving previously unsolvable problems on a recurring basis. And that's creating millions of dollars in value each year. And you can have the most accurate model in the world, but if it's not integrated into workflows, configured for those use cases, and providing actionable insights, it won't deliver results, and it would live in this data science silo. So with the application layer, you unlock the true value of visual intelligence. And consider DeepSeek's recent breakthrough. They offer ChatGPT level performance at a fraction of the cost, made very easy to customize and tweak everything around the model. But the big impact was not about model capability. It was about creating an accessible application layer for millions of people to interact with and to modify and to power new business models. Now that's incredibly powerful and very impactful.
Yeah, powerful and impactful indeed. Great stuff, Galdens. Thank you. Nico, if I can turn to you. So how does the application layer apply specifically to visual intelligence?
Yeah, the application layer for VGI includes several critical and challenging components. First of all, and what a lot of our clients don't think will be the first challenge, is that we need to be able to connect to cameras, right? And we need to be able to efficiently process the information and incoming frames that come from those cameras. And that's actually a big challenge here, because it's about very, very large volumes of data that need to be processed at scale. And then once we are connected to those cameras, we need ways to tell the VGI system what it should do, where it should integrate, and what the use case and outcomes should look like. And once that's done, we need to install the systems somewhere to run it, right? So a robust and secure deployment architecture is needed that enables edge computing and centralized management across hundreds or even thousands of devices and cameras. Think of your system scaling across geographies. And then once the VGI systems are up and running, we need configuration tools that allow dynamic customization, speaking of setting up detection zones, adjusting thresholds, defining workflows, all remotely and in real time. And then finally, we need human-in-the-loop feedback mechanisms that turn user corrections back into system improvements.
That's really clear and powerfully summarized, if I might say. Thank you. To bring it just a little more to life, Galdens, what might be an example of how the application layer changes outcomes then?
So we can deploy the same core model in, let's say, 2 different manufacturing facilities. In one facility, it's just sending alerts about incidents that get ignored. In the other, it's an integrated model setup that connects with incident management systems to trigger automated responses, generating dashboards that drive behavioral change, and providing real-time insight that coach supervisors as well as the people using the system themselves. That shows it's the same model with completely different business impact. And the application layer is what bridges from detection into action.
Got it. That's a fascinating distinction, actually. And turning to you, Nico, in the context of that, then, how does the application layer enable VGI to scale across different industries?
For me, the modularity is crucial. So VGI systems need to adapt to manufacturing quality control, construction safety monitoring, logistics, vehicle tracking, vastly different contexts with different requirements. And the application layer provides this adaptability. You're not rebuilding the entire system for each use case. You're reconfiguring the deployment interface and integration points while actually leveraging the same underlying visual intelligence.
Thank you both. I'd love right now, and I'm guessing many of our watchers would as well, to explore how VGI will transform specific industries. Starting with manufacturing, as we just covered before, how does VGI go beyond current quality control systems? Gaudence, what are your thoughts on that?
So current systems detect defects that match predefined patterns as they are detected. And VGI would predict quality issues before they manifest. So it can observe subtle changes in operator behavior, environmental changes in equipment wear, or material characteristics that precede defects. So it goes from detecting to observing and understanding. And more importantly, it connects visual observations to operational context. It might notice that defect rates increase when certain operators work overtime, how safety hazards correlate with different shifts, or identify near-miss situations that otherwise would go unreported. Moving from detection and reaction to prediction turns hidden risks into avoided costs and translating into this multi-million-dollar impact across organizations that occur each year.
Thanks, Gaudence. So that's manufacturing. Over to you now, Nico. What about construction?
Well, compared to manufacturing, construction environments are incredibly dynamic, right? The layouts change daily, weather affects conditions, and teams rotate frequently. And current systems or current safety systems struggle with this variability. But VGI adapts in real time. It understands that temporary scaffolding creates new hazard zones, recognizes when weather conditions require different safety protocols, and can predict high-risk periods based on crew fatigue patterns and environmental factors. So I think we're moving from compliance monitoring to proactive risk prevention.
Yeah, that point on proactive prevention is absolutely key. So how might this apply beyond safety to broader operational efficiency? Gaudence?
Let's look at lean management. So lean is the backbone of efficient manufacturing in modern facilities today. It's about cutting wastes, moving the workflows, and increasing the output. But today, it's still mostly done through occasional walkthroughs and audits with clipboards, people standing there looking at what's happening. And VGI enables what we call continuous lean optimization. It can identify workflow bottlenecks as they form, flag underused machines in real time, and identify process inefficiencies through visual understanding. So for example, it might observe that material staging layouts cause unnecessary movement, or that certain equipment configurations create productivity losses. And those insights drive ongoing operational improvements rather than just this periodic assessment. So the result is a non-stop improvement. It's factories that get better with every shift based on accumulating learnings across a large network of different locations and factories that work together. Also a great example of how VGI scales and standardizes previously these isolated methods like spot assessments that can be just deployed on an ongoing basis.
Wow, that is really exciting, considering that's here and now. So are there applications you see on the horizon beyond these more traditional industrial cases?
Yeah, in short, absolutely. So for example, in energy, it's about predicting infrastructure fatigue by forecasting failure of equipment on oil rigs or wind farms weeks in advance, way earlier than every conventional method would even flag issues. In warehousing, totally different industry, you see continuously analyzed inventory levels and transportation bottlenecks for flow optimization based on insights to optimize layouts strategically. In the healthcare industry, It's about identifying equipment risks to improve the quality of procedures. And looking into construction, for example, there we see a dynamic site hazard mapping about creating proactive alerts before hazards occur on a large scale. So the key insight is that once you achieve general visual intelligence, the applications become limitless. You're not just building separate systems for each use case, you're applying the same visual reasoning capability across diverse domains and applications.
Fantastic. So that more than covers off the challenges and enablers of VGI. Some great use cases there and real world applications. What about market dynamics? What market dynamics are accelerating the shift toward VGI?
I'd like to take this one, Jeremy, as I touched on it previously. I see major convergences that are creating this inflection point, and we've covered it earlier, how the foundation model revolution has shown how general purpose AI outperforms task-specific approaches. Open source models have democratized access to cutting-edge capabilities. And then we also highlighted hardware democratization, making real-time processing economically viable and scalable for the first time. And if we add into this the data efficiency breakthroughs, we see how all three trends converge.
Thanks. That is really clear and compelling. Thank you, Nico. If I can turn to you now, Gaudens, I'm left wondering on this, how these technical advances translate to business drivers.
So today, organizations are realizing that incremental improvements to existing systems won't deliver transformational outcomes. VGI represents a fundamental capability leap that can differentiate competitive positioning of entire business models within their industries. Research from McKinsey estimates that visual intelligence applications could actually add over 4% to global GDP annually. That's nearly $5 trillion, a staggering amount. However, we believe that may well be just the beginning. As we covered before, VGI applications are truly limitless, very powerful, and effectively infinite, as every organization requires their own custom applications throughout all of their workflows.
Thank you, Gaudens. It really is extraordinary, that GDP impact statistic. So Nico, what about the economic case studies that we're seeing now?
Yeah, I think breakthroughs that drive technical innovations and decreasing computation costs are particularly relevant, as Gaudens mentioned, because modern architectures can match the performance of systems that once required billions in investment, but at the fraction of the development costs. And we're already seeing real economic case studies. For example, manufacturers reducing unplanned downtime by 30% through VGI-enabled predictive maintenance, or construction companies increasing productivity through equipment utilization tracking. Such use cases have a significant impact on productivity and margins. And as model and tooling breakthroughs continue, paired with simpler user interfaces and cheaper hardware, these advanced VGI capabilities will become accessible to far more organizations out there, multiplying the economic gains across entire sectors. And this then suggests that VGI could become widely accessible very, very quickly, cutting development time and cost by orders of magnitude.
Great stuff, Nico. Thank you. I think it's clear from what we've covered so far that the emergence of VGI has a truly mind-blowing potential. I'm wondering now about obstacles to overcome, Gaudens. What do you think the primary barriers organizations face in moving towards VGI, and how can they be addressed?
Interestingly, we see that the biggest barrier isn't technical, it's conceptual. Many organizations are still thinking in terms of narrow and isolated AI applications rather than a general visual intelligence platform. They want to solve specific problems individually rather than building adaptive capabilities to replicate success. And this technological shift requires also a shift in thinking about vision systems as intelligent infrastructure rather than a series of standalone point solutions.
Right. That makes perfect sense. So once we're beyond the conceptual challenges, Nico, what about some of the practical implementation challenges?
We can't get around the fact that, as with any major breakthroughs in technology, integration complexity, also with VGI, is significant. VGI systems need to connect with existing business processes, data systems, operational workflows, and this requires careful change management and system architecture planning. However, modern VGI platforms are designed for incremental deployment. So as with AI vision today, you can start with pilot implementations, prove value quickly, and then scale systematically rather than requiring extensive infrastructure changes and infrastructure redesign at the start.
Got it. So in the same way as AI vision readiness, Gowden's, how do you see organizations evaluating readiness and then clearing their path to benefiting from VGI?
From where we are today, we recommend starting with use case mapping. It's about identifying where visual intelligence can deliver the highest impact in the shortest time possible. Actually, we use a quadrant chart to have both dimensions mapping out. And then we assess existing infrastructure. We look into data availability and organizational change readiness. The teams need to be open to adopt this framework of a fast-changing technology system rather than just buying a conventional standalone IT system through traditional procurement processes. So the key insight is that AI vision builds on existing camera infrastructure. You're not replacing everything, as Nico just said. You're adding intelligence to assets that are already in place. And once you're ideally equipped to embrace the power of computer vision today, the next leap is going to be to unlock the value of VGI. And that's going to be much clearer and simpler to achieve from there.
Right, got it. Okay, that makes me wonder then, how would you say organizations, how should they best prepare today for this trajectory to VGI? What do you think on that, Nico?
I would say that the goal is to go beyond deploying AI vision and take a longer term view, namely to start preparing to build adaptive visual intelligence capabilities. So the organizations that establish VGI foundations today will be best positioned for future advances. Focus on modular, scalable architectures that can evolve with improving capabilities. Most importantly, develop organizational competencies in visual intelligence deployment and management. The technical capabilities will continue advancing, and I believe the differentiator will be implementation excellence.
Thank you both, especially for making that both insightful and clear. Something we come up against quite often is how advanced AI vision capabilities naturally raise some privacy and even ethical concerns. How do you think organizations should approach these considerations? Nico, do you want to take that one?
Sure, one of my favorite questions as it comes up in every webinar and interview. For us, this is a key point to address from the very outset. Privacy by design, I think, is non-negotiable in our world and locked into how we work every day. AI vision systems, doesn't matter if they are VGI enabled or beforehand, should use edge computing to process all data locally, minimizing data transmission to the cloud. Also, the use of object blurring technology makes sure that all data is fully anonymized. And then for us, it is also important to be fully compliant with GDPR and the EU AI Act, as well as certify all infrastructure with the gold standards like ISO 27001 and SOC 2 and all those exciting certifications. And then transparency is equally important. Teams need to understand how systems work, what data is collected and how it's used, because transparency builds trust, and trust is essential, especially in addressing privacy.
Thanks, Nico. Privacy by design and transparency are clearly essential in addressing any potential fears. Gowden's, what about any surveillance concerns?
I think they're valid because without guardrails, any powerful technology can cross lines and eventually will cross lines? I think the answer is purposeful design. VGI should serve people as an autonomous decision support system. That's why involving the workforce from the beginning into building and also operating it is essential. In fact, VGI is the evolution that repurposes the conventional cameras that involve human operators that basically look at the video and move away from the need of this manual surveillance to systems that are truly collaborative as human-machine approach-based systems where users can provide feedback that improve the system by using it, and also to improve the work outcomes of everyone involved, preventing injuries and increasing productivity. We also mentioned before how improving the systems work, right? By providing this feedback on a data level, just commenting on the quality of events that are flagged. And compliance has to be built into the system. On the app layer, it's important to give full visibility about what happens and why, with simple controls for all data flows and all model settings. It shouldn't be a black box. It needs to be auditable, fully adjustable, and explainable. And I think this is required for VGI to become a trusted safety and efficiency infrastructure with people naturally in the loop. And in the end, this is also cultural as much as technical.
Indeed. Thanks, Gaudens. Nico, what about ensuring ethical implementation?
Again, I think it's important that we always establish ethical frameworks before actual deployment. So this includes clear policies on data usage, algorithm transparency, and human oversight requirements. And most importantly, we involve stakeholders early in the design and deployment process, because at the end, ethical AI means also collaborative AI.
Absolutely. Thanks both for that. So let's move to organizations interested in exploring AI vision today and then preparing for VGI. What would be the recommended approach? Nico?
Emphasizing what we mentioned earlier, I think it's important to start with implementations focused on the highest value use cases, mapping existing camera infrastructure and identifying where intelligent analysis would deliver immediate benefits, because proof of concepts and pilot deployments can be live within days and not months. And the key is beginning with problems that have a clear measurable outcome. So for example, safety incident reduction, quality improvement, efficiency optimization, and then success in initial deployments creates this momentum for broader adoption and for scale.
That makes perfect sense. Thank you. And then Gaudens, for today and also the future, what resources do organizations need?
The answer is it's actually far less than most people might assume. It's not billions. Modern AI vision platforms leverage existing network and CCTV infrastructure that already exist and provide cloud-based management interfaces. So the biggest investment is usually in change management and user training rather than the technical infrastructure itself. And with the right infrastructure in place, most organizations break even within just a few months. Once the system scales across more workstations, entire facilities, the ROI also grows faster, and applications can be rolled out across all workstations and facilities to multiply that value that's generated rapidly.
Wow, thank you both so much there. It feels like as we're drawing closer to the end, this might be a good point to recap briefly, if I may. So as we've heard in fantastic detail, visual general intelligence, it's more than just the next stage in computer vision. We believe it's the bridge to a future where machines perceive, reason, and act with human level understanding of the visual world. And that's from manufacturing and logistics to healthcare and energy. VGI's promises not just incremental improvements, but a fundamental reshaping of how organizations ensure safety, efficiency, and innovation, just as we've heard. This leap from narrow task-bound vision systems to adaptive context-aware intelligence marks a milestone on the road towards the zeitgeist topic, artificial general intelligence itself, and crucially one that businesses can begin preparing for right now. So for me, the takeaway is clear. The future of AI will be won not by those who simply experiment with isolated use cases, right? But by those who build adaptive visual intelligence into the very fabric of their operations. VGI is not a distant concept. It is actually an emerging reality. And that's powered by accessible infrastructure, scalable platforms, and ethical frameworks designed for trust. So we truly see this moment as an inflection point. And as you've heard, it's the chance to shape the future of human-machine collaboration, where vision becomes intelligence and intelligence then becomes impact. We're very excited because the opportunity is here right now and it's limitless. So in the interest of time, I'm going to pass back to you, Chrissy, for some questions. And thanks once again. That was amazing.
Of course. Time really has gone away with us. Thank you, Galdens, Nico, Jeremy, for such a fascinating exploration of VGI. What's been discussed today really does represent more than that incremental technology improvement. It really, truly is a fundamental shift towards machines that truly see and understand the world. VGI promises to transform how we approach safety, efficiency, and innovation across every industry. And we're seeing that in the questions today that have been coming through. So the floor continues to be open. I've bundled a few questions together to try and help us solve a few, kill a few birds with one stone. So maybe, Galdens, if I can start you here. What's the fastest way to start this? Like, have you got a 90-day plan?
So it's important to simplify everything and begin with one or two high impact use cases. Suitable ones involve safety incidents, quality or workflow improvements, then run a pilot, measure hard outcomes, and then scale. And do it in that sequence alone. You can usually build on existing cameras, add intelligence on top of those, and expand then once the first value has been proven. And you have to start at the very beginning and follow through with very clear metrics that are measurable. It cannot be just general soft values.
Yeah, absolutely. Okay, and another one here actually for you, maybe, Nico, this time. What are the core technical components organizations need to implement AI vision systems?
Well, first and foremost, you need IP cameras. You need a camera. Those are usually conventional cameras for which the IT team can provide what we call an RTSP stream so that we can connect to the streams. And then you need an edge computing device to process streams locally. So essentially a small computer that is placed close to where the cameras are or in the same local network. This is all quite simple and straightforward. The software side is where it gets a bit trickier. It includes model serving and orchestration, application logic, data stores, human-in-the-loop interfaces, model training, annotation, privacy and security tools, and more. And that's what we combined all into one ecosystem that provides the entire software side in one platform.
Yeah, great. Okay. I'll squeeze another one in relation to ROI, because that's important to everybody on this call, no doubt. Maybe, Galdens, can you take this? How do you quantify the business value of VGI compared to a traditional computer vision approach?
Okay, so classic computer vision is today's reality and the first phase of stepping into VGI. Generally, VGI is more context-aware and predictive and expanding on the application layer, whereas the computer vision is more related to data science problems. It's easiest to quantify value where cash actually moves to avoid unplanned downtime, prevent injuries, increase throughput, and automate manual work. I would always focus on cash saving use cases. And while introducing AI vision across the portfolio of locations is possible, the value creation always occurs through 3 phases. The first phase, it's about detecting what happens. It's about using computer vision to create visibility and no longer flying blindly and making decisions now based on data. In the next phase, it's about creating an impact to reduce the volume of detected issues. And in the final phase, it's about stabilizing that now decreased volume of issues on a lower level and stabilizing like the impact of computer vision on the organization.
Great. Okay. I'm very conscious of time. So I think what we'll do is wrap up on questions there. I will reach out to those of you that have positioned other questions, and we'll be able to individually give you some feedback on those. So thank you once again for joining today's discussion, gents. Just a couple of last things I wanted to share. We have created a white paper discussing the emergence of VGI, which will be available in the coming week or so. So if you would like to receive the kind of a sneak peek version of this before launch day, please feel free to go to this link and request. Secondly, since you're all forward-thinking professionals, we would like to offer you the opportunity to receive a free AI safety audit. This is a service we normally include as part of our paid pilot programs, but it complementary to you guys, it will deliver real actionable insights into how AI can enhance safety across your operations. So if it's something you're interested in, you can either go to the link shown here or look out for the follow-up email from us in the coming days, which will have the on-demand webinar too. Demand has been pretty high for this, so be sure to let us know if you would like to see that. And then finally, just a heads up that our next webinar will be on the 30th of September, and we'll be featuring a fireside chat with one of our customers, HDI. They are really putting our technology to work and seeing some incredible outcomes. So we're really looking forward to sharing their story with you too. We will include a registration link in the follow-up email from today as well. So once again, thank you to all of you for joining us, and I really hope you enjoyed today's session. And we'll see you next time. Thank you so much. Bye-bye.
Thank you.
Thank you.